Yes, hi guys. We are doing question number 8. Okay, and A part here for first part of this. What is the first part? Question number 8. Okay, part number 1 or this is first part here. Let me take first part. It says the sine inverse x. Okay, sine inverse of. Okay, I've just cleaned the board. After clearing the board, I'm taking it again. Okay, this is sine inverse of minus x equal to minus sine inverse x. This we have to prove here. Okay, this is the first part of question number 8. We will do it. Okay, let me continue our solution. Let us take okay, theta is equal to sine inverse x. Or let me take not like this, let me take minus x equal to sine theta. Okay, let us take minus x equal to sine theta. This implies that theta is equal to sine inverse minus x from this. Theta equal to sine inverse minus x. Or from here, this implies that this is okay related to this theta equal to this. Let me take this first equation. But minus x equal to sine theta. Okay, that implies that x equal to minus sine theta. X equal to minus sine theta here. Okay, or we can write it as sine theta equal to, or this is minus sine theta here. Okay, but minus sine theta, we know that what is minus sine theta. We can write it as sine of minus theta, because we know that sine is an odd function. So sine minus theta equal to minus sine theta. We can write like this. Okay, so now if I just take it, therefore sine inverse x minus theta equal to, from these two we can take it. This implies that sine inverse x is equal to minus theta. But theta is, we considered here, theta is sine inverse x. This is theta equal to sine inverse x, sine inverse minus x. Value of theta we are substitute. The theta equal to minus theta equal to this. If I take minus sine to this side, or I could write here that theta is equal to minus sine inverse x from this one. Now put the value of theta, or theta is sine inverse minus x, which is equal to minus sine inverse x. Try to understand. This I just substituted, but let me take not to substitute this one. Let me take this. Now sine inverse x equal to minus theta, or theta equal to minus sine, take to this side, is minus sine inverse x. But theta is sine inverse minus. So we are substituting from first equation. This is, let me take second equation. From first and second, this let me write here. From first and second, we have obtained this. We have obtained this final result. We have obtained it. We have obtained this. Okay, so this is the value of theta equal to minus sine inverse x, and theta is sine inverse under root of sine inverse of minus x. That I have substituted it from this sine inverse x, from this value. Sine of inverse of x equal to minus theta. This is minus theta. Take minus sign to this side. It is theta equal to minus sine inverse x. This is second equation. Now value of theta, which is this one from first equation, we have substituted here. Therefore sine inverse of minus x is equal to minus sine inverse x. Hence proved. So this is probably the first question is proved. Let me take the second part of this. What is the second part? Let me just check it. Okay, let us prove the second part of this. Okay, now we have to prove lines. Wait. Okay, now we have to prove the second part of question number 8, or B part of this. What is that? Let me just check it. Now B part say cos inverse. Okay. Now second part of this, B part of this is cos inverse of minus x equal to cos inverse x positive element. This is cos inverse, pi minus cos inverse x. That is the value here. So this is going to, we have to prove that this is pi minus cos inverse x. Cos inverse of minus x equal to pi minus cos inverse of x. Okay, let's see. Again, solution. Let minus x, this minus x equal to cos theta. Okay. So this implies that again theta is equal to cos inverse of minus x. This formula. Okay, this is first equation. Let me take. But this one minus x equal to cos theta implies that x equal to minus cos theta. Now we can write it as what is this? This is can be written as cos. We know the second quadrant. In second quadrant, cos is negative. Cos pi minus theta equal to minus cos theta. So in place of minus cos theta, we have written down here cos of pi minus theta, because in the second quadrant, this pi minus theta angle is falling in the second quadrant. Now in the second quadrant, cos is negative. In the second and third quadrant, cos negative. Okay, so this is lying in the second quadrant. Cos pi minus theta is minus cos theta. In place of minus cos theta, we have written down here cos pi minus theta. What is this now? Therefore, cos inverse x, this equal to pi minus theta. From the properties we have just taken this cos to this side, so it will be cos inverse of x equal to pi minus theta. Okay, now in place of this theta, we can substitute here this. This is equal to pi minus cos inverse of minus x. This is equal to cos inverse of x. Okay, so this is the value here, or we have to prove that pi minus cos inverse x. If I take this to this side and cos inverse to that side, or cos inverse of minus x is equal to pi minus cos inverse x. Take this to this side, or from here itself, theta could be taken to this side and cos inverse to that side, or theta is equal to pi minus cos inverse x. Now in place of theta, we have substituted this value here, which is cos inverse of minus x equal to, this is pi minus cos inverse x. Hence, cos inverse of minus x equal to pi minus cos inverse x. Hence it is proved. This is your right hand side here. Hence proved. Let me write here, hence proved. This one, cos inverse of minus x equal to pi minus cos inverse x. Okay, so hence it is proved. This is the second part of this. This is to be understood. Why? Because minus cos theta can be written as cos of pi minus theta. We cannot write as cos minus theta, because cos minus theta is positive. Cos of minus theta cannot be written as minus cos theta. In place of that, we have written down here cos pi minus theta. Okay, because cos pi minus theta is negative cos theta. In second quadrant, cos is negative, and pi minus theta is cos sin. Okay, like that. So it will be directly minus cos theta. That is the point. You will note it down. This is pi minus theta, therefore it will be cos inverse x. Take minus theta to this side, cos inverse to that side. Theta equal to pi minus cos inverse x. Put the value of theta here on this equation. So theta is cos inverse of minus x. Okay, so hence this is the second part of question number 8. Okay, let us take third part of this. What is the third part of this stage? Okay, third part. Third part is third part is tan inverse of minus x. We have to prove that tan inverse of minus x equal to minus tan inverse x. That is the point here. Okay, so tan inverse of minus x equal to minus tan inverse x. That we have to do here. This is third part. So let us take here. Let this minus x equal to tan theta again. Let's assume. Okay, so again this implies that theta is equal to tan inverse of minus x or tan arc of minus x. Some people pronounce it as tan arc of minus x, maybe, or tan inverse of minus x. That we have to write. Okay, pronounce here. So pronunciation of this may be theta equal to tan inverse of minus x or tan arc of minus x. Okay, this is the equation number 1. From this is realized. But this value minus x equal to tan theta implies that x equal to minus tan theta can be written as tan of minus theta. Why? Because tan of minus theta is minus tan theta. This is odd function. Tan, sine, okay, cosec, cot. All these 4 are odd functions. Sine and secant and cos or cosine. These 2 are even functions. So they doesn't matter if we put minus sign in the with the angle. Okay, in case of cos that is positive, but in this case it is negative. Minus tan theta we can write like this: tan minus theta equal to minus tan theta. From here, what this further implies that tan inverse x, tan inverse of x is equal to minus theta. Okay. Now we can write here value of theta. What is that? This one theta is tan inverse x. This is tan inverse of minus x. Tan inverse x. Therefore, tan inverse under root. Further, this implies that tan inverse of minus x equal to minus tan inverse x. This 3 had to take this minus sign to this side. So we take from this. This implies that theta is equal to minus tan inverse x. Theta equal to minus tan inverse x. This is the value here. Theta equal to minus tan inverse x. Okay. The value, place value of substitute value of theta. Theta is tan inverse of minus x. So therefore, tan inverse of minus x equal to minus tan inverse x. Hence, if it has been proved, or we can say this is the right hand side. Here, tan inverse minus x we took here in place of theta. We have just proved, and it is proved. We are not taking left hand side or right hand side. We have to prove that tan inverse of minus x equal to minus tan. We always assume this minus x equal to tan theta in this way. Whatever the trigonometric function is given, that we assume minus x equal to that value, and after that we solve this question. So this is part number 3 of question number 8. Let me talk about what is part 4 of this question. Part 4 or fourth part of this. What is that? Let me check. Fourth part of this is cot inverse of minus x equal to pi minus, I think it is pi minus cot inverse. Yeah, it is pi minus, let us take. It is pi minus cot inverse of x. Pi minus cot inverse of x. Okay. In that case, we have to prove this. In this case, we have to prove this. No problem, we can prove this. Okay. So let us take again. Proof or solution. Let minus x equal to cot theta. This implies that theta is equal to cot inverse of minus x. This is your first equation. Or minus x equal to cot theta implies that x equal to minus cot theta. Now minus cot theta can be written, we can write cot minus theta, but we can write, because cot in the second quadrant is negative, we can write cot phi minus theta, but this will give us minus cot theta also. Cot minus theta, if we have to prove that this is equal to minus cot inverse of x, in that situation we have to take cot minus theta, okay, because that will also give us negative sign. But we have to prove here pi minus something. Because of that we have taken this pi minus theta. So minus cot theta is cot pi minus theta, because cot pi minus theta is minus cot theta. Alright, so from this cot inverse, therefore this implies that cot inverse of x is equal to pi minus theta. Okay, take this theta to this side and cot inverse to that side, or theta is equal to pi minus cot inverse x. Theta equal to cot inverse x. Okay, now put the value of theta, which is this one. The first one, this is the second equation that we take. From first and second. From first and second we get theta, which is cot inverse of minus x equal to pi minus cot inverse x. Pi minus cot inverse x. Okay, this is your result transport. Hence prove here cot inverse of minus x equal to pi minus cot inverse x, which I have to prove. Now we have proved this. This is pi minus cot inverse of x. Okay, actually this is the fourth part of question number 8 complete. Okay, no other questions are given because that are not taken. Similarly, we can prove the other two in case of cosec inverse of minus x, and similarly of secant inverse of minus x. Okay, those two questions can also be written down in the same way. In case of sec inverse, it is pi minus sec inverse x. Okay, because if I write those, then please prove yourself. Let me take fifth part is cosec inverse of minus x equal to minus cosec inverse x, and sixth part is, which are not written down here, that secant inverse of minus x equal to pi minus sec inverse of x. That can be proved easily, or we can write here pi minus this one, no problem. No, this cannot be written as pi minus because cos is positive, cosec is positive in the second one. Only this can be written as pi minus. Okay, so these two results are shall proved. Similarly, as we have proved the other four parts, we can prove these parts also. Okay, this is question number 8 now completed. These two options are given to further questions which one can solve in the same way, which are not noted down here. Now let us take 9th question. Question number 9, A part of this. There are a number of parts here. How many parts? Only 3 parts are there. Let me take first A part. A part is 2 sin inverse x. We have to prove that this is equal to sin inverse of twice x under root 1 minus x square. That we have to prove here. Okay, so let us take sin inverse x equal to theta. Let sin inverse x equal to theta, or x equal to sin theta. We could take x equal to sin theta. Then theta equal to this. We have taken this as this. Okay, so that is the point here. Now, therefore, cos inverse x equal to, or if I take sin 2 theta in that situation, x equal to this sin theta. Now we know that what is sin 2 theta equal to. since sine 2 theta is equal to 2 sine theta into cos theta, that we know, or it can be written as 2 into sine theta we are taking as x, and cos theta can be written as 1 minus sine square theta, which is twice x under root 1 minus x square, because sine theta is, this is first equation are taken here. The solution we are finding out. Solution of this, or proof of this. Okay, so what we assumed, we took sine inverse x equal to theta, and after that x equal to sine theta, or we could take x equal to sine theta, no problem. Okay, sorry. So this sine 2 theta, we know that 2 sine theta cos theta, this is the formula. Since this, you know, this is identity here, we know this. Okay, so from the trigonometric identity, sine 2 theta equal to sine theta cos theta. Now 2 sine theta is x, so this is x. Cos theta can be written as under root 1 minus sine square theta, that is 1 minus x square. This is sine 2 theta equal. Or 2 theta, is equal to, take sine inverse to that side. The sine inverse of twice x under root 1 minus x square. 2 into theta, what is theta? Sine inverse x. Therefore, 2 into sine inverse x equal to sine inverse twice x under root 1 minus x square. This has been put here. Okay, this is how we have to put this and prove. So this we just assume sine theta equal to x, or put x equal to sine theta. In that situation, let's solve this question. This is part A of question number 9. Let us take next parts of question number 9. What is the B part of this? Let me take that also. Okay. B part of question number 9. Now it says that 2 into cos inverse x equal to, this is cos inverse of 2x square minus 1. Again, let cos inverse x equal to theta, or let x equal to cos theta. We can take in this way, or theta equal to cos inverse x. This we assume from this x equal to cos theta. Now cos 2 theta is equal to, we know that this is 2 cos square theta minus 1. There are 3 formulas for this. 2 cos square theta minus 1, 4 formulae. 2 cos square theta minus 1, 1 minus 2 sin square theta, cos square theta minus sin square theta, and 1 minus tan square theta upon 1 plus tan square theta, that is also in terms of tan theta. Cos 2 theta has 4 values here that we have to. Let us take 2 cos square theta minus 1. Okay, cos 2 theta equal, or from this, if I substitute value of cos theta, which we have taken x, this is 2x square minus 1, cos 2 theta equal to, or 2 into theta is equal to cos inverse of this, 2 into x square minus 1. Substitute the value of theta, this is cos inverse, or 2 into cos inverse x equal to cos inverse twice x square minus 1. Twice x square minus 1. Right. And it is proved. And it's proved. This is the question here that we have to answer. Okay. Sorry. This is the hence proved question. 2 cos square, 2 cos inverse x equal to cos inverse 2x square minus 1. We have proved this. Simply, we assume that let cos inverse x equal to theta, or this is cos inverse x equal to theta be assumed, or let x equal to cos theta. Then theta equal to cos inverse x, that is implied there. Now cos 2 theta, we know that formula of cos 2 theta. Okay, 2 cos square theta minus 1. The true value of cos theta, which is x here, so this is 2x square minus 1. So 2 theta equal to cos inverse 2x square minus 1. And 2 into theta is cos inverse x equal to cos inverse of 2x square minus 1 times 2. This is the question here. Okay, so question number 9, B part, and school. Let us take next part of this, and that is your C part. What is C part of this question? Let me check. C part of this. Question number 9, C part. Now it says 2 into tan inverse x equal to tan inverse 2 into x upon 1 minus x square. This we have to prove. Okay, so let us take this. Let us assume that x equal to tan theta. This implies that theta is equal to tan inverse x. Since we know this, since tan 2 theta is equal to, what the formula for tan 2 theta? We know this is nothing but 2 tan theta upon 1 minus tan square theta. This is the formula from trigonometric identity. Okay, this is trigonometric identity. We know about this. Cos 2 theta equal to this. Now substituting the value of tan theta, which is x, this is twice x upon 1 minus x square. Value of tan 2 theta equal to tan theta, take to that side, or 2 theta therefore is equal to tan inverse 2x upon 1 minus x square. We take this tan to that side, it becomes tan inverse of this. 2 theta is equal to tan inverse of 2x upon 1 minus x square. Put the value of theta here, or 2 into tan inverse x equal to tan inverse of 2x upon 1 minus x square. That is the value here. Okay, and it's proved. To prove tan inverse x equal to tan inverse 2x upon 1 minus x square. This we know about. Okay, let's take next question. Okay, ninth question is completed. Question number 9 now complete. Let us take other questions. Now, what is the other question? Let me check it. 10th, question number 10. Now, question number 10 says that prove that 2 into tan inverse, 2 into, to prove here, to prove 2 tan inverse x equal. Let me take that. Here, 2 into tan inverse. This one, 2 into tan inverse x equal to sine inverse of, here, where is that? Okay, sine inverse of 2x upon 1 plus x square is equal to cos inverse 1 minus x square upon 1 plus x square is equal to tan inverse 2x upon 1 minus x square. In this case, 2x upon 1 minus x square in case of tan inverse. With all these three, we have to do 1, 2, 3 resistors. Okay, let us take. Now we know that. Sorry, if I take separately those values, So first of all, let us take solution here. Let x equal to tan theta. This implies that theta equal to theta equal to absolute tan theta, or theta equal to tan inverse x in this case. Let us take theta. This is the same value we have taken. This we have assumed here. Okay. But tan 2 theta, what we know about tan 2 theta is equal to 2 tan theta, let me take upon 1 minus tan square theta. This we know about, or equal to 2 into x upon 1 minus x square, or 2 theta is equal to tan inverse 2x upon 1 minus x square. We just proved, okay, above. This is 2 into tan inverse x, or 2 into tan inverse x theta is tan inverse x, 2 or 2 tan inverse x equal to this tan inverse 2x upon 1 minus x. So this is, let me take first result. Secondly, and since sine 2 theta, if I take sine 2 theta is equal to, this is 2 tan theta, we know this in terms of tan theta, upon 1 plus tan square theta. Why? You can write in terms of tan theta because this 2 sine tan theta means sin theta upon cos theta, and this is second square theta. Second square theta is 1 upon cos square theta, 1 cos cancelled out. This is the same thing, sin theta upon cos theta, sec square theta, so it will be 2 sin theta cos theta in the numerator. That means sin square theta. Value of sin theta is 2 sin theta cos theta. From this we will get the same thing, 2 sin theta cos theta. Why? Because this is 2 sin theta upon cos theta in the numerator. The denominator we have second square theta, because 1 percent second square theta. But second square theta is 1 upon cos square theta. But if you take cos square theta in the numerator, and it was sine upon cos, so 1 cos cancelled out, which is 2 sin theta cos theta. We can write in this